and fuzzy logic, I want one feedback from you. Before this whenever the selective option was given to you, I shared one course information sheet. I just wanted to know whether you received it or not. Has it helped you to decide or not? Anyone?
Yes, sir, we receive it, and for me personally, I think that was a very big thing for help me select which PE I would have wanted because all the PEs were pretty interesting.
Okay, good, good, good. So nice to know that it helped you to some extent. Well, so a formal welcome to all of you to the NNFL class of 2021. And this is a beautiful subject, I'll tell you. I'll guarantee you that. And let's see how the journey will flow in. We'll see that. So, first of all, I would like to say that thank you for believing me, and then say, uh, so you believe in my beliefs. So then you say, what the hell is your belief, man? So, my belief is something like you may say that it's a passion and fun of learning a mathematically intensive course. When I say mathematically intensive code, doesn't mean that in a traditional maths we keep on scribbling this equations, derivations, without any motto and particular objective. No, here we have this mathematical tools. So whatever the mathematics we'll approach in this particular course is completely from a tools perspective. Unfortunately, maths is not being taught the way it should be, like a tools perspective. So actually, when I say this tools perspective, means we'll come to know this, what this tool is meant for, how do I know that when to invoke this tool, for what kind of application. So that will be the approach we'll feel that. So some of you may be feeling this intimidated, oh my God, this guy is talking about the maths and I don't like maths. So no problem. So soon we'll say, okay, ye dil mange more kind of stuff. And it'll happen. Don't worry about it. Provided you just be with me and enjoy this journey. How this will happen? Because I don't teach the maths the way it is being taught here or anywhere in India. Because the way I have approached maths in completely different way. Is completely different way means when I was learning as my during my college years here itself or in Delhi. So it was completely from a tools perspective as far as my perception or reception is concerned. So I don't want to give you a knowledge of this mathematics or this particular subject, only the conceptual. I want you to have a perceptual knowledge. So there's a difference between conceptual and perceptual. So conceptually, you just know something like this is sad, something, and perceptually you do and feel it and exactly know that does it make sense or not. So with that particular perspective, when we approach maths, it will be really fun. It won't be boring anymore at all. So this is my claim, and I assure you that I'll do it, provided you just being honest with me that later whether I could do it or not. And so that's why I said that how will you do it? So we'll get it by basic understanding and uses of those mathematical tools. So I'm not saying mathematical concepts, rather I'm saying mathematical tools. So you may say, what man, it's just another word you're saying. No, no, it's completely different perspective altogether. Because when you take about the tools, and then you say this, okay, I don't have to remember so many things. So whenever required, I'll try to pick a tool. So only thing what I remember is that in this particular scenario, what are the tools will be more useful or helpful for me to solve this particular problem. So that we'll see. And whenever, if you remember the which tools, the rest of the details of the tool you will come to know very easily. This off the shelf information is available, you can get it. So today I'll talk about this presentation means another half an hour or so. So we'll see about this, what is neural network of visual logic itself, and what is the course objective and course content. First of all, we'll also look into it and delve a little bit on it, that what this name is neural network and fuzzy logic. There's completely two different dimension altogether, or whether they meet somewhere asymptotically. So we'll see that. And also we'll try to understand what is the course objective, what I had planned, and the course content. Course content is already shared with you, but still we'll discuss over here. And finally, the learning outcome, which I recently revised factually yesterday only. So what is the outcome I'm expecting from you? And then there is a textbooks available here, and what we'll refer to. An assessment plan, what I mentioned here is completely traditional in nature. There is offline class. I'm expecting that soon we may open, but we don't know. If otherwise, we have to wait whatever academy section they decide. So we'll go as per the plan. And then we'll have this course web is not now. Actually, I used to have traditionally on Piazza. So Piazza has gone on paid version. So I'm avoiding it. And also we'll look into the office hours, what is that, and I'll discuss about it, and the policy on LOR policy, because later you should not have a setback. Man, I just enrolled in your class, I was there, so I need a LOR, and you're supposed to give it. No, big no. So there are certain conditions which I put forth, and if you meet that, you are most welcome to get a LOR from me. Now, this, as we know this, so basically whenever we talk about neural networks, so we are not talking about something biological neurons. So we'll be talking about artificial neural network. So whenever we use word neural network, we'll not say explicitly artificial neural network, rather we'll say just neural network. Okay. So these are the computational models inspired by human central nervous system. So you'll be surprised that it was way back somebody had described it and something called C.Y. Castle, early 19. And also you'll be surprised that in the history of Nobel laureates in the last 100 years, a maximum number of this Nobel has been given in physiology for people who have studied some sort of working of brain or the part of neuron or something of that sort. Significant number in physiology has been given to those people. So C.Y. Castle was the first person who completely tried to give a structure on handwritten kind of structure or drawn structure and about the neurons, and rest others might have found something and they come out with a very abstractive idea of the mathematical models how it works. But to be very honest with you, there is no study at currently which can say that this kind of mathematical model completely emulates at least one neuron in the human brain. Similar to that, they say similar but not exactly. So you can imagine that we are given god gifted so many things for us. And even these asymptotic models of the neurons, they are able to do so many things in the world, you can see in an amazing way. Imagine the day when it will come that human brain will be able to abstract its own functioning. And that, when I say abstraction, what I mean to say from a mathematical perspective and in terms of modeling also, if they're able to do it, maybe now or 100 years down the line, you can imagine that what can be done by machines itself. So I don't know, that will be a blessing in disguise or something else, but the day will come sooner or later, maybe in our life, maybe beyond. But it will come. So this ANN are capable of machine learning and pattern recognition. Those things are very much part and parcel of it. And some applications have you listed, and you know that the people who are in this particular group, I know that they are well aware of this machine learning and the neural network. They are all talking about deep learning, etc. Deep learning and all kind of auto encoders, transformer, this bot model, blah blah. So many things they talk about, something even I've never heard of, or I'm not able to keep a pace with that. You can say that. So there are so many. So just to name a few representative examples I've taken here. Something is called function approximation. So this, you know, that function approximation probably you have done first year mathematics, regression analysis, time series prediction, fitness approximation, and modeling. When I say modeling, any behavior modeling when where some sort of computation is done. And it can be done for the classification using pattern, sequence recognition, novelty detection, sequential decision making, to name a few. And of course, when I say this list is definitely not exhaustive in any way. There are so many things to be done and to be listed, but you can just give us a representative idea that what the neural networks can do. Again, I'm reminding you that neural networks, when I say it is referring to artificial neural network. Okay. So this is the first part we'll be dealing with. A major part of your course is completely neural networks, around 75%, you can see that. And 25% is regarding the fuzzy logic. And then we'll try to understand this, means in a couple of minutes I'll talk about it, that what's the relation between the two. So I want a question from you. Do you categorize people as a successful or unsuccessful? Only two categories in life? Do we say something like that? Anybody? Just speak out. It's okay. Shout as much as possible.
No, sir.
Hello?
Sir,
Do what we do?
So there are multiple. For instance, they can be moderately successful as well. So that is in between the two.
Yes. So we don't say, like human beings don't say is on time or not on time, something like somewhat late, somewhat early, somewhat successful, not successful, very successful. So what I'm trying to say that there are various degrees of this truth, etc. Isn't it? There are various degrees. But our traditional way of system, which a machine works, is completely in Boolean logic. Either a 0 and 1 means either true, false, or you can say successful or unsuccessful. But in reality, we don't do this. So there is a beautiful theory which was given by this a person from UCB way back in 96 too, and they talk about something called fuzzy legs. So there is a great story about it, and this sometime I'll narrate. So this fuzzy logic was given by Lotfi Zadeh from University of California from Berkeley, and this guy is basically from Azerbaijan, and he's still there. He's still there in very advanced age. And actually, when way back in 60s, he came out with this idea about this mathematical modeling of the human language, the symbolic, the way we say somewhat okay, okay, good, all this. When he tried to model this various degrees, and he wrote a paper and tried to publish this particular paper, people rejected it outrightly, and this idea was rejected by many journals. So you can imagine that somebody at the station who is from UCB, University of California, Berkeley, and he is writing something, and that idea is getting rejected. It's how painful and irritating also. But he didn't give up this, and he's tried to publish, but rejection from anywhere after facing. Finally, he was editor-in-chief of a particular journal. He publishes there itself, right? So what was the reason behind this? Those people who were rejecting this idea, this is outrightly absurd. They felt that it is not possible. How can you mathematically model something like that? So sometime, even though you may sound 100% correct to yourself, but the world won't listen to you. So if you have faith in yourself, you should not give it up. Keep trying. And some or the other way, if you make your this idea or discovery, etc., known to one, not immediately down the lines, people will come to know its value. But you have to have first faith in me, faith in yourself. It doesn't mean that you come out with the idea and Sanjay says or some ABCD says, no, no, it's nonsense. It is cannot be done. So they say nonsense or it is not possible based on their understanding at that particular time, right? But that may not be true. Because somebody has not thought of like this doesn't mean that it's not correct. Okay. But if you have firm belief in yourself and your idea, then you keep on, your perseverance should be there and you keep on trying for that. So this is what this Lotfi did. And once his paper came out in public domain, that is, it was got published, people found so interesting and they found application in myriad ways. And so many applications are there. Now it's used in your phrase, in your car. Now they talk about this like in phrase, it will give you some sort of signal when water goes less or something kind of defrosting and all many things. Even the cars also people talk about say computer in car. Matis was the first. So that was a microprocessor chip also, but many things are there, especially in control systems, fuzzy logic you use heavily earlier, but now it is being used in many different ways. So we'll see. So whenever you have many various degrees or grades of truth or the one even to be expressed mathematically, which a conventional approach of Boolean logic does not allow you to do, you can do is using fuzzy logic. Now and some application comes like decision making here, fuzzy classification, fuzzy pattern recognition, control system, and many more. Then now a very obvious question comes to mind. Okay, man, this neural network I know because so many paper you must be reading and working, some of you, what the hell is this fuzzy logic, why these two combined? Because it's like you feel that okay, the two shall never meet, but I'll tell you asymptotically it is going to meet because there is a branch of this one we'll be calling called neurofuzzy system. So neurofuzzy systems basically, so this I'll translate it to some extent later. So in basically in I'll tell you now very abstractly, which may not be able to decipher by you, but this will help you to understand that why these two concepts are there in one particular subject. They are not completely mutually exclusive, What happens that in fuzzy logic, there is a term, something called membership function, or what you call grade of truth. So computing that is a very difficult task from the traditional approach. So we use neural networks to find those values. And that's why, and such kind of system where these two things work together, what is called neurofuzzy system. So the final conclusion chapter of this particular course is what we'll be calling as a neurofuzzy system. Okay, so we'll see that. Now, so that was all about this, basically what is neural network, means what we study and all these things, and what is fuzzy and how they're related. Now, the basic course objective is to have fundamental understanding of the engineering issue underlying the design of neural network and fuzzy log system. When I say engineering, what I mean to say completely a design approach, means design principles or the paradigms which you use for this designing a neural networks and fuzzy log system. And then we have another objective is to have an understanding of conceptual and mathematical foundation of neural networks and fuzzy logic. So first one, you'll be looking for engineering issue, means how do you go for designing and all. And the second is, if actually it should be swapped, I should say. First, and then we should have this understanding about this required mathematics for neural part and fuzzy part as well. And this the third one is basically to have basic proficiency in using neural network fuzzy logic toolbox if you use MATLAB. If not, I would suggest you to learn Python. And remember this third objective part regarding this the coding part, etc., will not be taught in this class. This is something you have to do. So I would suggest you to go with the pace with the path now. So I would suggest you that in probably quickly in a 10 days or a week or so, get yourself acquainted with PyTorch, because PyTorch is the now current tool for this all neural network part of it, or machine learning also, and it will help you in a long way. I do aware that, or I'm aware that you are already familiar with Python. I suppose you had some labs and you have gone through the Python course and Python lab. But I suggest you to get acquainted with the PyTorch, and which is aggressively used by this machine learning and neural network community over there. So this, remember that I'll not be teaching you this part, but don't worry, a question will also not be asked for this. But you have to study, because to just make that your learning is complete in all the perspective. And okay, so this is for that. And regarding this course content, if you remember that I talk about this few mathematical prerequisites for this particular course. So basically only there are three pillars for this course. One is mathematical prerequisite, another neural network, and point of fuzzy logic. So if you see this here, so this what I mean to say, we need set theory. When I say set theory, whatever studied in the 9th class of set theory is sufficient and more than enough for us. We don't have to go for a very high or deeper level of set theory. If you know what is union, what is intersection, what is set difference, what isn't, all these basic 3 or 4 operations, that is enough for us. Then when I say this A inverse something adjoint of A by A, what I mean to say that you should know the operation of linear algebra. If that is comfortable for you, which you have studied in the first year itself, that is enough, but some of them I'll review also. And here I mentioned dxn by dx, so nxn minus 1. So even if you just know that how x square is differentiated with respect to x, that is 2x over there. So that's enough. Even so, this part of differential equation is differential method is enough for us. And then we have something called integral symbol. So this is what I mean to say. This integral calculus is also required for us. So if you said, oh man, I forgot all those things, this integral differential calculus, don't talk about all those things. No. It's very easy, man. I'm not looking for a very deeper or integration by parts and all, or many other theorems. I'm just looking for that if you can integrate x and dx, which is nothing but you can say xn plus 1 by n plus 1, even that is enough for us. And finally, when I say here this particular thing, what I mentioned is Bayes theorem. So when I say Bayes theorems, it's a representative of this probability theory. So when I say probability theory, a lot many things has to be talked about it. So I'll cover uh, whatever the concept is required as and when required. Okay, we'll do this. Now that's so instead of going for this entire mathematical prerequisite in one go, we'll go as and when required. Like today, I'll complete this only the linear algebra. Rest small concepts are required, so I'll cover as I go. Okay. Then we go for the neural networks part. So in this series, we'll be talking about neural models, means what people prompted people to abstract the functioning of human brain and how they have abstracted it. When I say abstracted, means mathematical representation of that. Then we go for some sort of learning process. So this is quite classical in nature, though there are many advanced learning style, but these are the basic building blocks on which you can build rest of the thing. So you may point me and some of me disagree with me that, oh man, this is the classical technique of learning process you're teaching us. And there are so much advancement. I do agree with that. But classical still mathematics is so advanced, but plus minus mathematics, multiplication and division, the basic operation remains same. So others are just built on that. So like some basic learning process we'll also discuss and we'll see. Then we'll talk about something called single layer perceptron, then multi-layer perceptron, and this multi-layer perceptron will give an idea about this deep learning process. And I'll talk about a simple representative network, which will give an idea how a deep learning network works. Then we'll see about the radial basis function, and we'll talk about support vector machine. So the people who took my machine learning class in the last semester, they will have this only overlapping idea of support vector machine. But here I want to tell them but the approach of support vector machine in this particular course is completely different what we have done earlier. Means approach idea remains same, but the way we derive these equations of this optimization problem, this primary problem and secondary problem or dual problem, that will be completely different style altogether. And if time permits, we'll see PCA, but PCA still I'll not be able to cover it till this fuzzy I complete. So in fuzzy part, first initially, we'll try to understand what is fuzzy set and what is crisp set. When I say crisp set, it is nothing but a classical sets. The set we are familiar with, which you have done so far. So it is that only. And then we'll translate the idea from the crisp set to fuzzy set and try to understand a clear-cut difference between that difference between the two. Then we'll say that a mathematical relation which we have seen so far, binary relation or something like that, how do I translate that particular part in fuzzy? Then we'll talk about membership function. And the fourth module in this will talk about fuzzy logic and inference. And here, this will be the concluding chapter. We'll be talking about something called neurofuzzy system. And with that, we'll close this particular loop. The neural network is completed, fuzzy is done, and then we'll see that neurofuzzy system. Now in fuzzy part, what we'll do, because fuzzy, you'll be surprised, entire mathematics of so many years which you have studied so far will be completely zero for this fuzzy. So there is a strong caveat for that. So we'll see that how do we unlearn those things. Whatever we know about the mathematics, we have to forget it when it comes to the fuzzy part. So there will be a little transition difficulty initially because the kind of mathematics is being done here is quite different. And but this was quite fun. But we'll approach a simple thing, two-step process. First, we'll take in a traditional crisp set theory approach, means a classical set theory approach. Then we'll translate those ideas slowly to fuzzy set environment, and we'll see how things are working. Okay, so this is all about the course content we'll discuss. Now, any queries so far here?
So
Yeah.
So you mentioned a part about the PyTorch thing for us because it's being aggressively used right now. Can you just share some resources, whichever you think is the best resources to study PyTorch? Because most of us, I think, if we use neural networks, we are into Keras and TensorFlow.
Okay. I look into it. Basically, I would suggest you that, but I'll check myself. Some course are a MOOC you can take for easy and quick learning. So it will help in two ways. Like first of all, you'll get a quick and dirty way of programming in PyTorch. When I say dirty, what I mean is not actually dirty. What I'm trying to say that quickly you got some idea, right? And why I'm saying dirty, because you are not gone through in a rigorous way. So you know that at a very shallow level, but still you know that how to start with a PyTorch program and go ahead with that, how to compile, etc., and write a simple a neural network model and design into that. So I look into it. First of all, it will serve you this particular purpose. Second, you'll also get a certificate or course array things which is that it comes free for you. So I'll look into it and get back to it. but I sincerely suggest you to complete it, though it is not a some sort of what's a graded assignment or something like that. This is completely for you, and I'll explain you why I need those things. So in a couple of minutes. Apart from that, anybody else? Anyway, we have a Q&A here, so we'll discuss those things. And now at the end of this particular course, and please, you are free to write me, criticize me at the end of the course if I'm not able to serve you in these lines. Understand the conceptual issue behind the working of neural network-based system. When I say conceptual issue means, and at the same time perceptual means you'll be doing with your PyTorch and see, yes, what Sanjay said, it's working in this way, and yet it does, and you are able to visualize this. Now understand the conceptual issue behind the working of fuzzy logic-based system. And fuzzy-based system can be programmed as classical classical PyTorch. Sorry, meaning PyTorch without PyTorch, simple Python program itself. But PyTorch, if you're using one and good, and we'll see that how will you able to apply various mathematical tools to design neural network-based system for the given application at the same time for this fuzzy logic-based system. At the same time, also means if I give a scenario to you, now you should be in a position to first of all recognize that this particular problem scenario or the problem, can it be solved by neuro alone? Can it be solved by fuzzy alone? Or should I club them? And does it solve? So this kind of scenario. So analyze a given problem scenario and design a neurofuzzy based logic based system for the given application. And the last one, which is my pet one, that if you really follow this particular course properly, when I mean to say properly means simply not nogging and going away, no, be there. And then this one, I'll be covering sufficient mathematical formalism and tools so that you'll be able to read, comprehend, and convey the content of any research paper in the area of neuro or fuzzy. So when I say this, so you should be doing, and we have one exercise in this particular course, which I have designed it. So I'll try to grade it somehow, but if it is not happening, so I'm helpless because hand tied by academic section, they have some restrictions. I cannot decide my own grading policy, basically evaluation policy. But but we'll try to find it out. As long as it benefits you, is fine for me. I'm ready to work on extra mile for that. And the textbook, when I say the first one is the basic textbook for you, Simon Hickey, Neural Networks and Learning Machine, third edition, and it may be available online as well. So this book you have to refer to. And then this is the normal, will be covering the 5 to 6 chapters from this. And the second one by this Hagen et al. So this is useful as well as from programming perspective. If you decide to go and get an idea, means how do I design matrices, etc. And particularly using MATLAB, because this book is completely based on MATLAB. Or you can see the MATLAB tool for this neural network was designed from this particular book. Then another one, which is the recent one by Charu from IBM Watson Lab. So his book is Neural Networks and Deep Learning. So this is also available free of cost from our library online also. So if you have EJET proxy access to the library, I think you must be having it, then you can access the Springer link, and from that you can download this book pretty easily. Then fourth one, that is we'll be using our fuzzy part will be covered from this. That is the fuzzy logic with engineering application. So Timothy Ross. So this also you may get online, you can get it. And the fifth and sixth is basically IEEE transactions on neural networks and learning machines systems. And another is another IEEE transaction fuzzy systems. So these two particular journals I'll referring you. I'll be referring you to give some assignment, reading assignments for some papers from that. Okay. And then this assessment plan is not new. It's pretty, as I told you, that I kept it in a classical in nature, so like offline mode. But this semester, this plan has to be released by academic section people yet. But you may be knowing much better than me because since Corona call started, so students know more about the rules than we know. We know quite late, so you must be knowing it much better. But we'll see. Now this office hours. So when I say office hour, doesn't mean that 9 to 5 is office hours for you. No, office hours means one particular time, one particular hour in a week I have reserved for you, and I'll be available for you dedicatedly, whether you come or don't come. So this applies to both the scenario, either online and offline. Suppose if you resume the classes also, so I'll be there offline in my chamber for you to meet. And if you're online, definitely. So I'll be, thanks to this Teams and all. So this Corona call also is a blessing in disguise for many things. So henceforth, I'll be available in both mode, offline and online. So anybody who's there in hostel, they can communicate. Or if they want to comes down to the college, if in case we open for offline, you are most welcome. But I'm really very busy guy. You may not be having an idea. I'm very, very busy person. So I don't entertain anybody in between. Even faculty people don't bother to or dare to enter my chamber unnecessarily. No. So I'll be having so much work. So you're not welcome unnecessarily. So you may meet me during office hours only, and that is which is scheduled on every Saturday between 10:30 to 11:30. I've gone through your timetable, and I was informed that in your batch 2018, in seventh semester there is no seminar, no lab, so enough time you have. Of course, you have this placement to look into it, but you can imagine the kind of work or the engagements your seniors had who were so busy with all this placement and classes. Apart from that, they have a seminar, two labs. So those seminar and labs, I think, has been removed for you. So good. So during this time, I'll be available. And if you have any query at the middle of the night, you are reading and you had some doubt, better you post it on MS Teams. And definitely you cannot expect any answer from me at that time, but I'll be able to reply very immediate time whenever I see next immediately, right? So, and best will be that if you have a doubt, simply just don't keep mum, keep shouting to your teams and not a problem without bothering this. That my question may sounds very idiotic to others. It's very, very basic. No, 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 no. My question is question itself. If some doubt I have, it is a doubt. Others really don't care. So you have that kind of you can say mindset. Don't worry about what others will think. If you're a doubt, try to raise. But if you're not able to raise this query in the class, okay, you can put it in this Teams message, or you can meet me during office hours without any hesitation, and it's okay. And I don't shrug about this doubts, etc., because I had a doubt always, and I myself face a lot of problem during my studies period. If I have a simple doubt, and if I ask these teachers, and they'll just "चल बाहर जा खड़ा हो जा simple परेशान करता रहता है." Nothing of that sort. I had a very simple doubt. Teachers in APGP class in 11th class, he says that okay, now we'll apply binomial theorem. So I obviously ask very simple question: how do I know that I have to apply binomial theorem now? It's a very genuine doubt, don't you think so? If somebody say apply this, wait, how do I know that I have to apply this? Now you're saying it's fine, but I should get to know some signals, right? When I'm solving a problem. But such kind of problem I face in many part time in my academic life. So not to blame the teachers, because probably they have been trained like that, or they didn't bother to go an extra mile and to explore themselves. But I had this irritating fact that until unless I really get to know how and why, until unless these two things I get answers, especially why, I won't proceed further. So I suppose that you people use WS family to great extent, whatever it may be, and without bothering that it will irritate. No, no, it won't irritate, because I had a difficult journey. So I'm covering at this, and I know that it has made me a better person while exploring those kind of question, right? Being here at a student at MIT, especially in ENC, and there's my many questions could not get answered, and you know that teachers have their own way of proceeding. So no, no, they either they get irritated or something like that. Don't worry about it. Just raise your query as and when you have, without bothering that it will irritate teacher. No, definitely it will not irritate me. Whether it will cause some sort of public shame in my teams because I had this simple doubt. No, as I told you, no doubt is simple or complex. As long as it's not clear to me, it's not clear to me, and I want it. I expect that it should be clarified, and you have a right to ask for it. Please go ahead with that. And then the question comes, man, okay, I can't wait till Saturday. Saturday is far away, and I want my doubt to be clear and in person, not in this masses also. So drop me a mail, and definitely I'll get back to you immediately. But remember that I don't check my mail every now and then because I really hate this concept of wherever I go, my network follows. No, no, I don't use mobile phones. So this the stupid idiot box I keep at home. So my mail checking timing is like only thrice a day. That is the morning, 10 o'clock, afternoon, 3 o'clock, and night, 9 o'clock. Only these three timings I just check my email, and accordingly you can expect the response at that time. So you cannot expect that in middle of the night you send me same mail or I reply. No, no. But early morning, 10 or 10:30, you get a reply. Accordingly, you do that. So you may meet me on any day during 10:30 or 3:30 p.m. provided I am free. This is the case if you come to campus, and I hope and we are really praying that you should come and things better. So also remember that I really don't entertain anybody for doubt clarification during sessional or end sem examination. The reason or the rationale behind is that if you did not bother to study during the entire semester, and during your sessional all your dimaki batti started blowing in night, middle of night, and you have so many questions, so I should not be troubled that time because it was your fault. You didn't bother to listen to the class or clarify the doubt that time. So I don't entertain anybody for during sessional exams, assignments, or end semester examination. So I'm just telling you very in advance. So this is the case, and then we'll start with this, and then some policies on LOR. So I'm telling you, this is something, a policy which is completely offline. I'll tell you, since Corona started, I stopped giving LORs to people. The reason being that I have got a good reputation among this Ivy League university as far as recommender is concerned. And during this Corona time, whatever we do, it is not ensured that the people who get the grade, they are the actual scorers of there. Because people collaborate. I'm not using the word copying. I'm saying collaborate. They collaborate so much. Everybody having high grade, high grade. So this is the policy for this my offline class. So if you, let's say in case if this comes, so only because you have taken my course, so 5 LOR I'll give you, provided a particular person has scored at least B grade and above, at least. And believe me, it's not so easy. And also, LORs will be provided only once. When I say once, means you applied this year and then could not make it, so next year you ask somebody else, because it still takes a little time to do all the filling process and all. And another one is that, so, but people who work with me and have some papers with me, there is no limit ceiling for them. The reason is that the people who are work with me, I closely monitor their behavior, the perseverance, the how they work, their intellectual contribution, and all kind of other traits, and that helps me to evaluate them properly. So for them, I have no ceiling for that, and I'll keep submitting till they get it. Okay. Now, it's time for you to uh, uh, put forth your query. Just a minute. I'll stop this meeting for recording for a time and then we'll start again because